This is a generalized coordinate. They are used as an abstraction that represents the coordinates of a reference frame. In classical mechanics, we use the letter q with an index I to represent every coordinate. For example, in Cartesian coordinates, q1 represents x, q2 represents y, and q3 represents z. The power of generalized coordinates is that they allow us to describe the path of a particle simply by making q time dependent. This parameterizes the spatial coordinates with time, which turns them into functions of t. We can also build generalized velocities and accelerations by taking its time derivative and second derivative, respectively. And the good news is that because any physical system is only concerned with positions, velocities, and accelerations, we can express any equation of motion by making use of q, q dot, and q dot dot only. What is the best selection of generalized coordinates we can make for a given system? In the previous examples, we chose the entire basis to build our QS, so Q represented X and Y. But as a good practice, we only select the minimum number of independent coordinates we can, and it's important to remark the word independent. For example, imagine that the path of a particle is described by the following curve. Here, the height y clearly depends on the coordinate x, so we can relate both with an equation. Whenever we can do this, we say that there is a constraint that reduces the digress of freedom. This constraint is always given by an equation of the form f equals 0, where f is a function of the spatial coordinates and time. More specifically, for d spatial dimensions, n particles, and c constraints, the degrees of freedom of a system is d times n minus c, which also turns out to be the ideal number of generalized coordinates. Thanks a million for watching. See you next time.